So far, we have already learned about the blowfish encryption algorithm. Now we're going to learn about the AES algorithm standard. So here, what you can see that the family of the symmetric key block cipher, that means that AES is also a part of the symmetric key block cipher, and it's an industry standard encryption algorithm, and it's much stronger than blowfish. That means blowfish is weaker now, but AES it's much stronger. And why? Because blowfish only uses 64-bit block size, but AES uses 128-bit block size. And what's the block size? The block size is, let's say there's a large file. From there he will take 128 bits at a time, and then he will make the blocks of 128 bits, and then he will encrypt those blocks. So it's a block kind of encryption system. And then bytes per block, here it was 8 byte for 64 bit, and here it is 16 bytes. Okay, so the key size here it's 32 to 448 bits, and here the key size is fixed 128, 192, and 256 bits. And network type is phase tail network, and this one is substitution or permutation network. These are high level things. We're just having a glance at these things. So security is legacy, and this one is modern standard security is used for AES encryption. So AES is much more modern. So encrypting with the AES256 using GPG. So we have already used GPG to encrypt encrypt in the blowfish algorithm, but now we're going to use the AES256 algorithm. That means now we have a file that we want to encrypt this file. So I need an algorithm or a machine to encrypt this, and the machine's name will be AES256, and we also need a passphrase. We'll give it later on. Then with this machine and passphrase, this whole thing, it will be encrypted, and it will give me a unreadable encrypted file. And to get back the original file from here, I need to again use that passphrase to recover the file. And this is a kind of symmetric. So here the key for encryption and the key for decryption both will be same. So what we can do, we're just doing the same thing. Blowfish.plain, that file we are just copying it as AES256.plain. No problem. So we are just going to, let's do it from raw structure. Okay, so what we did a little bit ago was we're just taking this content and we'll save it into the AES256.plain file. So now I have a plain text file, and what is inside this file? As you can see, there is this content that I am given here. Okay, now I want to encrypt this one using GPG. So what my command will be, let's see. So obviously we're going to use the GPG. So we're going to use GPG, and then we're going to tell that it's a symmetric key encryption. So -c for symmetric, and then we'll say that dash cipher algorithm. So which algorithm are we going to use? This is AES256. AES256 algorithm is going to be used, and the file name that we want to encrypt is going to be AES256.plain. So if I enter this command, it will ask me for a password. So let's give it a password. Okay, the password is very weak, so it's giving me a warning, but let's just continue with this one. So now it has been converted. Now if I just want to list the file that we have just encrypted, let's see, this one was the main file, and this is the .gpg. This is the encrypted file of this file, and you can see this one was only 41 byte size, but this one is 123 size. Okay, so the size is almost 3 times. Okay, and if we want to see what is the encrypted file, if I just cat it out, then it's going to be like this, which is encrypted. We can prove it. Okay, so that's how we can encrypt a file. And obviously if you want to decrypt this file, then we have to again use the GPG. So let's do one thing, GPG -- decrypt, and the file name will be AES256.plain.gpg. So it has been just decrypted, and it has given me the main content. and the password is not asked because the password has been already saved in the cache. But if you want to see that how it is going to ask for the password, we can do one thing, that is remove the cache. Oh, sorry, not. I had a command to remove the cache. Okay, I'm so sorry. This is how I can remove the cache, and if I want to decrypt it again, which will normally happen, he will ask me the password. So I have to give the password. If I correctly give it, then he will give me the decrypted file. And if I give an incorrect password, let's see what it. Oh no, it's again the password is saved in the cache. So let's try to decrypt it again. And if I give a wrong password, it's going to tell me decryption failed because I entered bad session key or the bad passphrase. Right. So this is about the AES encryption. And if we come back to our lesson, these are the methods that we have used. And AES uses 256-bit key here in this case. And if we check the file type, let's see what we get. So file, it will give me the file type of the AES256.plain.jpg. Then it is going to say me that it's a PGP symmetrically encrypted data, and it is AES algorithm has been used here, and 256-bit key salted and iterated. Okay, so 256-bit salted and iterated SHA-512 has been used with this one, which is the AES algorithm's process of working. So I think it's clear to us. Next, we're going to check the file type check, and then obviously it's done. We have checked these things, and this is also done. So what's the key takeaway from this lesson? The key takeaway is that Blowfish and the AES are block ciphers. So these are block ciphers. It takes particular blocks of a file and encrypts the blocks at a time, not like stream cipher. The stream cipher, it does what? It takes only one byte at a time and encrypts it, but it takes a block size. Blowfish uses 64-bit block size, but AES uses 128-bit block size, and AES supports the 128, 192, and 256-bit keys. And GPG supports multiple cryptographic functions. So using GPG, we could do AES, and we could also do the Blowfish. And encrypted files are obviously larger. We have seen the size is larger, and the encrypted files are binary. You can see these are binary files, which is not readable characters and unreadable without key. So you cannot read this without the key. And same plain text plus same password not equal same ciphertext across algorithms. That means, you see, when we did apply the AES256 on the same content, this same content, the encrypted file was like this. But when I used the same content in Blowfish, where is the Blowfish? This one. In the Blowfish, it was different. But I used the same passphrase and I used the same content, but the key was, the encrypted file was different. So this is the takeaway from this lesson.